All right, thank you so much. Thanks everyone for joining. Yeah, today we're going to be talking about the GDS Steiner algorithm and how it applies to Disney's four-park challenge. And let me just make sure my screen, there we go. So yeah, a few disclaimers before we get into it. One is that this talk is not affiliated with or sponsored by Disney. Also, the four-park challenge is an unofficial challenge done by fans. So with that out of the way, what is the four-park challenge? Well, in Orlando, Florida, there is Walt Disney World or Walt Disney World Resort, and there's four major theme parks. You'll see them pictured here on the screen. So the four-park challenge is you've got to visit all four theme parks in the same day, and you got to take a picture with the icon. Like you see the icons pictured here, like the Spaceship Earth or Tree of Life. You got to like purchase and consume one food item, and then do like a ride or attraction, say like the Pirates of the Caribbean ride in Magic Kingdom, for instance. Um, so what's that have to do with graph? Well, it's a pretty graphy problem if you want to like try to optimize your park experience. One is Disney itself has a very comprehensive park-to-park transportation system. They have a monorail. They've got like a boat or ferry. Got a Skyliner, which is sort of like a gondola. They have buses between each park. Also, within each park, there is lots of walking paths. So, like, say you're in the Magic Kingdom, and if you're at the Pirates of the Caribbean ride, it's like way on one side of the park. If you want to get to like the Seven Dwarfs Mine Train, there's at least like three different ways to get there. So there's a lot of like sort of pathfinding in this problem. Also, my wife and I, we did up the four park challenge by also doing all four modes of transportation in the same day. So let's talk about the GDS Steiner algorithm. It's one of the pathfinding algorithms in the Neo4j Graph Data Science Library. The actual specific name of the algorithm is called the minimum directed Steiner tree. And how it works is you pick a source node that could be like the park entrance, and then you pick some target nodes. So in this particular case, for the four park challenge, the target nodes would be things like a photo in front of the icon, or like a restaurant, or like an attraction. You can also specify a weight, and we'll talk about that on another slide. And when you run the algorithm, it returns a list of like node ID, parent ID, and that's like the start and the end of the relationship that it finds, plus the weight it returns back to you. So in order to make this work, I needed some input data, and I didn't feel comfortable like hacking the Disney APIs. And Google has the data, but they have some restrictions on licensing as far as how long you can cache it. So what I did was I actually vibe coded something using Claude, and using OpenStreetMaps was able to like bring it up in Leaflet, and then like hand draw or click on different waypoints on this Leaflet app. I'll give you a quick preview of it in a second. And then so that was for the transportation routes between parks and also within parks as well. Then I used the themeparks.wiki API, which has all the different attraction names and restaurant names and stuff like that. So that has an API with lat long values. So those got loaded on the map as well, and then I like manually connected them. So in the end, I had some CSV files that I exported, and then I imported those into Neo4j. So the graph model looks like this. You've got location is the primary like node label type, and locations are connected to other locations. So location can also have like an additional label or more additional labels. Well, you can have like the park name. It can have the like, I guess the transportation type, whether it's like a show or restaurant or something like that. And location nodes themselves, they have a point property. So the lat long is captured in actually stored as a point type property on the node itself. So given that each location node has like a start and an end node, then I calculated the distance in meters between the start and the end. And I was going to use that as the optimization thing, but I thought to myself, well, if you're walking, that's a lot slower than taking like the bus or the monorail. So really, like time is the important thing to optimize here. So what I did was I have some multipliers there. You see like the monorail is like 15.6 meters per second, bus 11.2, et cetera. And these are approximations, but they're fairly good approximations, I think, of how long it would take to get from one place to another. And then I added a few like additional times for like security, the entrance, or at a station. So how does this? So how do you actually use the GDS algorithm? So for one, you have to first do a GDS projection. And I'm not using the Aura Graph Analytics. This is using the GDS plugin. But what you do is that data was created in Neo4j is we're going to select it, and then you call this gds.graph.project, project it into this this projection. And then a few important notes here. I did specify the time in seconds as the relationship property that I'm going to use. And also I wanted to make sure that we projected it as undirected, which means that the relationship can go both ways, because if you're walking, you can like backtrack. However, there's certain considerations, like for the Skyliner, for instance, you can't turn around in midair. Like once you're in, you've got to finish the route. So there's one consideration for that I'll show you. Once you have your projection, then to run the algorithm, we have here, like I've started at the Magic Kingdom monorail station. That's the source node. Then I want to get to the Haunted Mansion, for instance. So I just picked one target node. So you specify that, then you run the algorithm, you get the results back here at this yield stuff, and then to actually reconstruct the relationships from the graph, you have to do this additional match statement. So like match p equals node parent, and you get back the path. So let's do a demo, and I'll show you what is going on. Just real quick, so here's a little bit about the data. This is just a sample of some of the data, and you'll see more in a second here. So go to the saved queries. So this is the Steiner tree. Let me make it a little bit bigger just in case you can't see that. This is the same query I had on the slides, where I'm starting at the monorail station, going to Haunted Mansion. If I run it, it looks like this. Actually, I made it too big, so let me zoom back out. Oops, let's see here. Well, anyway, maybe if I do window zoom out, view, that's what it is, view, zoom out. Okay, so we can see down here, we have the Magic Kingdom monorail station, and up here is Haunted Mansion, and they're connected by all these different waypoints. So that's one way to do it. You can add additional targets. So in this particular case, I have my starting point is going to be the Skyliner there, and then I want to go to all 4 different icon photo spots, plus like a ride in a restaurant here, and that's specified as my target nodes here. So we can do the same sort of thing. We run it, and it gets really busy, and I'll show you a better view of that in a second. Let's see. So this next one. I'll show you my vibe coded app here. So this is Leaflet. I think it's showing an OpenStreetMap here. I got a bunch of buttons, ignore those for now. But this is showing the Epcot paths around World Showcase. And one of the things I thought to myself was, well, how, if I'm over here at this La Hacienda de San Angel restaurant, how do I get over to Remy's Ratatouille Adventure? Because I can go around the left side or the right side. So what I did is actually ran the Steiner algorithm twice. I picked this as the source, and I picked like a waypoint over here somewhere, and over here as one path, and then started from here, and then a waypoint over here, and back here is another path. So that's what this other one here, which path is shorter. You'll see the union all here. And if I run this, instead of returning the path this time, I actually did calculation based on the weights that were returned. And you can see that going the left-hand side via Canada, England, France, or Canada, England is much faster than going the other way. So I wish I had known that before. Now I do. And one more thing before I show you a different demo is this is doing like the 4-park challenge and hitting like, all the icons, photo spots, hitting like at least one restaurant, one ride in each park. Then the additional thing here is the four modes of transportation for like the ferry and the Skyliner. What I had to do is I have like the Hollywood Studios ferry dock, for instance, ending at the Epcot ferry dock. I've got a waypoint on either side. So what I did though is this 0 to 20. It's going to let me navigate all the waypoints in between that, and that's going to be stored here in this path variable. And so then here, when I'm just picking my targets, I add those nodes here as additional targets. So that way, when it runs, it's going to get like it's going to use the complete path, so it doesn't turn around midway. So we can run that. And again, this one's not showing paths, it's just showing the full calculation. And it's saying like, if you're going to do this 4-park challenge, at minimum, you're going to be spending about 2 hours and 45 minutes, either in the transportation network or walking around. And yeah, I think I spent at least 2 hours on the transportation networks and a lot more time walking. So I could probably have optimized this a little better. But I didn't have this algorithm back in January. I didn't know about it. So there's a few minutes left here. You can do this in Explore as well. This is, unfortunately, there's no background map here, but this is Epcot World Showcase. And you see this is the La Hacienda over here. And down here is Remy, I think. Yep, that. So I'm going to clear this, though. And I'm going to run a different query, which is, if I didn't restrict my transportation options, what would it do? What would it tell me to do? So this, I'm going to zoom in a little bit. It's actually giving me the bus line between Magic Kingdom and Epcot. So here's Epcot. And you'll note that this time it's not giving me all of Epcot. It's just giving me exactly what I did, or what I had to do for the 4-park challenge, which is going to taking a picture with Spaceship Earth, doing Guardians of the Galaxy. This is a cut through with the restaurant. It's kind of cool. And then there's the restaurant down here, which is this Caramel Couche. And let's see, one more, and then we'll go back to the slides, clear that. So then we can do the same thing this time with all 4 modes of transportation. And this time, if I zoom in, you'll see I did take like the monorail here. So that's the gray nodes. And I took like the Skyliner at the beginning of the day from Caribbean Beach. And that brought me over here to Epcot. So this is Epcot. And this is the ferry line that goes between Epcot and Hollywood Studios. And there's also a Skyliner thing that's missing here because I didn't, it's there on the big map, but I didn't take that path. So this is just determining like how to do all these different things here. There's Star Tours, and over here is Animal Kingdom. So there's the Tree of Life. Yeah, so that's a quick whirlwind tour of how this thing works. Let me go back to the slides. Just want a couple of notes here. For the Steiner algorithm, I use this time in seconds to optimize, but the Steiner algorithm doesn't really care. Like if you're in manufacturing or a different domain, you could use something else like cost or score or points, whatever. You just need a numeric metric to optimize over. It's really whatever makes sense for the graph that you're working with. And a few resources for you here. This is a link to the GDS cipher projection. There's also a link to the minimum directed Steiner tree here, and excuse me, a link to the themeparks.wiki API. And you'll note that just happened to take a few more steps on this one day than normal. Yeah, so thank you so much for attending the talk, and there's my LinkedIn if you want to connect with me. And I think we have maybe, I don't know, 30 seconds for questions or something like that. So yeah. Any questions? Let's see. Have you considered putting together a book like this? Oh yeah, that would be a good idea, Ari. Yeah, I think we're all done. So appreciate everyone attending the talk.